Okay, we're trying to do number 1. -5 square roots of 3 minus 3 square roots of 3. Anyone feel confident with the answer? Okay, so I would put it times. So 2, that's only makes 1, right? -8 times square root of 3, okay, look at that. Does that make sense? Here it comes up with you agreed. Middle, if you think just 1 minute change, then it's good, and then runs down if you don't agree. Michelle, do you agree with -8 root 3? Kind of agree or don't agree? In that whole row, Haley, Utopia, Javin, Jesse, there you go. And thumbs up. Guess what? This is called combining like terms. These are like terms. This is the roots of 3. Look at the last name, roots of 3 family. So we're just adding up the quantities. The first one has -5. The second one has -3. So -5 minus 3 equals -8. And we don't change the radical. When you add watermelons plus watermelons, does it suddenly become a bunny? No, it's still watermelons, right? When you add watermelons plus watermelons, you still get watermelons. So you don't change the term. Now, there's one thing you need to check. Since the directions are simplified, does that root 3 simplify? Does it break down? No, because it's a special type of number. Prime number. So I need to go through and make sure when we insert the radical that we are boxing up a radical that's completely simplified. We might have to check factor on some of them. Okay, let's look down at number 5. So what is she critical to everyone? No! Here's another one. Hurry! Look at those radicals. Underneath the radicals, we would call them radicands. Look at those radicands. What do you know about those? They're all the same, which means we can have them. Great. Okay. Let's make it 3 minus 3. Good. Minus 3 more. Perfect. -9 roots of what? 27. They're all in the root 27 family. But I'm not going to box this up yet. I have to check. Can I break down 27? That's 27 prime. 27 is not prime, so you better check it. Roberto, can you give me 2 numbers that multiply to 27? You know, do you know this trick? I want 2 fingers and 7 fingers. I can put this down. 27. 4 fingers I put down. 1, 2. Third, what's this hand trick I'm getting? 9. So 3 times 9 equals 27. So 3 and 9. Have you got anything over there? So check this out. Okay, put all your hands on your hair. You can see my shadow. Okay? Look at me my leg. 9 times 7. Start here on the left and count 7 fingers over. 1, 2, 3, 4, 5, 6. Put the 7th finger down. How many are on the left side of the finger to put down? 60. How many over here? 3. So 9 times 7 is 63. What if we want to do 9 times 4? 1, 2, 3, 4. 36. Yeah? Yeah, especially until after 10. What about 9 times 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. Put your That's what's looking at from that. That's as far as that can go. Okay? Nice. It was pretty cool. Okay, so when you break down the nines, do you get nines? 3 and 2, right? So, we take all of those prime factors and write them underneath the radical. Can I say fingers in the air? What is the index of this radical? Fingers in the air, what is the index of this radical? Remember that little number that's here, or if it's not there, it's a certain number? Fingers in the air. Just see it, yeah? Use that corner. What's the index? Okay, what's the index on that one? Number 5, what's the index? 2. So here we have a grouping of 2 that we can pull out. Yeah, there's one pair. That leaves one guy behind. So we pull that 3 out. Does it become 3 minus 9? No. It times it 3 times negative 9. And then we pull something out and multiplies. 3 times negative 9. Riley Jensen. What is 3 times negative 9? Oh, you gotta switch things with me. Where is Riley Jensen? Okay, where's Abby? Okay, so I said it backwards. I'll just flip off that. Let me just that. Okay, Riley Jensen. What is 3 times negative 9? Good. Negative 27 rips out what was left underneath the radical. 3. Okay, and you have to get good at this simplified square when we did our quiz. Days ago, remember when we did one that wasn't multiplication? We simplified radical. It was so good. And one radical, and most of you missed it. And it was one problem exponents, and all the 2 people missed that one. So, it means we need to practice this more. Yeah? Then the radical will take on, and it'll just be negative 27. Yeah. Everything comes out, then the radical disappears. Okay? Let's look at this fun one. Number 9. Isn't that all exciting? I know, it's all extra credit. Okay, look at the right hands. Are they the same? No, they're not, right? Negative 3, 1 extreme, they're all different. The big thing about math is we teach a real life skill. That's what I'm looking for. It's called manipulation. You have to manipulate people in your life. I mean, last age, I manipulate my little brothers all the time, right? You tell little siblings, like, hey, go get me a drink. And then, like, sit on the couch or something. Like, go get a drink. Okay, so manipulation. I thought we could manipulate these 3, and then we do that by simplifying them and seeing if anything pulls out. So, to take the 3, that's not the hardest part of the whole thing. Because we think it doesn't break down, but it actually does. And look at the index. The index is not a 2 anymore. It's a 3. So I need 3 numbers that multiply to negative 3. Something times something times something is negative 3. Number 9. Does anyone have it? Okay, here's some options I'm hearing. Probably should have gone somewhere. Negative, what did you say, John? Okay, that's an option. Just put that in the margin. I think we want 2 more options. What if we had positive 3? What would we have have to multiply to get negative 3. Negative 1 and, can I use 2 negative 1s? So negative times negative again, negative? I have an odd number of negatives. And lastly, I can think of one other way. How can I do with the negative 3? Negative 1 times negative 1. Actually, I think even we make this a positive because I get this at 3, right? Times negative 1. Look at that. Positive 3 times 3 negative 1s. Is that going to be negative 3? Yeah, we can multiply by the 1s all day. That's what I'm going to use so I can get the negatives out. So, you have to like small be a big Henry because let's put it around over them already. Negative 3 cube root of 3 times negative 1 is parentheses, so it doesn't look like you're subtracting. Okay? Now let's break down the 162. Ooh, 162, no calculators. What are two numbers that go into 162? 4 probably goes in. Let's divide it longhand. I'm just doing this here because I want to record it. You can just find a corner. 4 into 162, let's see. How many 4s are in 16? 4. So 0. How many 4s are in the number 2? Ooh, okay. So not 4. 2 maybe because it's even. So how many 2s are in 16? 8. How many 2s are in 2? There we go. 81. So 2 times 81. And then 81 can be broken down into what, Haley? 9 and 9. 81 is what we call a perfect square because 9 times itself is 81. You can take the square root of it. And 9 will break down into 3 and 3, right? So on the outside we have plus 2 cube root. We have a 2 and 4 3's. Underneath that cube root there's a 2 and there's 4 3's. Just me? So what? Yeah. I'm going to make it bigger. Better? Okay. Okay, so now 2, break down to 81. Well, I think we already did that. So we already break down to 81. And what did we get out of it? 4 3's. So I'm just going to bring my thing down here. Don't forget about the multiplier in front. 3 times the cube root of 4 3's. Confused? Who's confused? What part? Tony? What part? Anthony? What part? Phil? What part? Okay. Do you understand how to do the factor tree? So you understand how to get to these numbers? So we just did that. This one's just a unique example of the first one. I don't think it's on the other columns. But, nice. So you know how you get this part where we line them all up, all those parts that you just got? Alex, no? All of these parts you in the factor tree, get inserted underneath. Okay, from the 81 tree to the 81 tree was right there. So at the end of the 81 tree, we're 3, or I guess it's 4 3's, 3 3 3 3. So we put all those underneath. Okay, so I'm just going to bring this guy down. This first radical is just the tricky one. How do we get the negative out? It's just a unique trick that we don't really see much in the other problems. Okay, on the first one, because of the index, what's the index? What's the index normally to apples? 3. So we have to have how many in our group? 3. So we have 3 in the first one. So then what number pulls out front? It's not a 1 though. What number was the match? It wasn't 1, 1, 1. It was negative 1 times negative 1 times negative 1. They're all negative 1. So when we pull it out, we have to multiply by a negative 1. Times by a negative 1. Anytime you pull out, it multiplies. 3 times negative 1 is positive 3. Roots of, what did it pull out? What's the only thing I do is circle? The 3. Yeah, this one's kind of long. Plus, look at the first one. Is there a grouping of 3? Right here. Group of 3. It pulls out. Right quarter is it? Is that what you said? Okay. Right quarter. When I was group of 3, what number is going to multiply in front? What? Exactly. Good. 3 times 2, I get 6. Roots of, look at what's remaining that's going to pull out. 2 and 3. But there's these dots between them. What do those dots mean? Multiply. So 2 times 3 is, oh my gosh, that's not 2 times 3. Let's try that. 6. Yeah? Okay, over here, the index is 3. Do we have a grouping of 3 of the same number? Yeah, so we can only take 3 of them. So what number multiplies in front? 3. 3 times 3, which is a positive 9. Cube roots of, anything left? 3. Yes, thank you. They should all be cube roots. Now look at the video on like terms. All 3 of them like terms? No, the middle guy is 6. Cube root of 6. This guy and this guy. So how many? Come on. 12. 3 plus 9 is 12 cube roots of 3. The radical doesn't change when you're adding. Plus, this one is not a like term. 6 cube roots of 6. That's the answer to number 9. That was a long one. So guess what? You didn't get your credit. So everything on the right-hand column on both sides is even, so you're assign it. Everything on the left-hand column are extra credit. Yeah? Coefficients. 3 plus the 9. The multipliers are their quantities. But it's a different family. This is a root. Cube root 3, cube root 3. We can put those together. This one's cube root 6. Oh, how do we get out of here? 53. Okay, we still have minutes. Yes? Just put that in your folder till the end of it, okay? Okay, can you guys be quiet, please? There's a question on the eating problems. Turn around, please. Turn around. Let me go eat until you guys are done talking. So this is good for all of you. It's at number 10. So get number 10 on your homework. Okay, your question? You can't back it up because it is a prime. If you try to do a factor tree, and it's a positive. Well, what would happen with the negative We have an even power. There's no way to have an even number of negatives to, well, we only do that trick when it's a negative underneath, to get a negative outside. But if it's an even underneath, don't worry about it, which I think the whole front page, that was the only one with the negative. But you can see right here, see that index 4? Isn't it going to get lighter but then the others? No. So you have to do a factor tree on the last 3. This one on the front doesn't actually break down. But that second term is not going to have anything combined with it. You can simplify. Those are like terms though. You can put those together. I'll start you on this one. How does 32 break down? 8 and 4. Okay, I'll do it that way. I want to see it like that. 8 and 4. Remember that shortcut for the 8s? 2, 2, 2. How does the 4 break down? 2 and 2. Okay, so underneath the 4th root, look at all those 2s. Devin, how many 2s are there? Yeah, I think there's 5. No, I think there's 5. And these guys are like terms. Look, 192s. So we can just add up the quantities and then break it down. Negative 3, that multiplier in front of the quantities. Negative 3 minus 2, how much is that? Negative 5, 6 minutes of 192. Yeah, I'm going to just tell you the next step, but then the rest is for you to solve. We need to do a factor tree for 192. Okay, then pull out anything you can from both of these radicals and see if you can combine some of them together. Lots of questions on that next time. Okay, it's time for questions on the purple paper. Yes? We do? Yeah. Sure. We just made our schedule today, but it hasn't been posted yet. You can come to it after school. Okay? Okay, pull out, or most of you have the purple one, and some of you might have had a yellow one, the one with the purple one. To me, I'm going to grab this. This is going to be white. One copy, so you're going to have to go to Canvas for that. She's black. You guys can talk Canvas, you can just print her out. She's brand new. That was my last copy.